Welcome, and thank you for joining us at Developer Summit 2021. This session about ArcGIS Enterprise on Kubernetes will give you a view into technical concepts, including some demonstrations about how we are building this new deployment option. Because we have not finalized all of the software, some elements of the UI that you see in the demos may vary from what's eventually launched. At Dev Summit 2021, you may also be interested in the companion session about ArcGIS Enterprise on Kubernetes and introduction. Let's begin.
Hello everyone, I'm Gayatri Vijay, Publishing Product Engineer for ArcGIS Enterprise. I'm going to present about publishing services in ArcGIS Enterprise on Kubernetes. The topics that will be covered in my presentation are map services, hosted feature services, and bulk publishing. Map services can be published from ArcGIS Pro. You can either publish by copying data to the server, or you can publish map services that reference data in a file share or a user-managed database data store. The enterprise databases that can be registered as user-managed data stores are SQL Server and Postgres. Database clients for these databases are built-in and need not be installed manually. We do not support Oracle database as of now. Map services can be published using either shared or dedicated instance. Overriding of map service from ArcGIS Pro is supported. Map service extensions that are supported are Feature Access, WMS, WFS, Network Analysis, and KMO. I'm going to demo publishing map service with Feature Access referencing registered data from ArcGIS Pro. This is my ArcGIS Pro, and you can see I'm signed into my Kubernetes portal. I have already authored a map and it is ready to be published as a map service. The data source for these layers are from a Postgres database. Click on Share, Web Layer, Publish Web Layer. I'm going to provide summary, tags. I'm publishing a map image layer, so I'll take the default. Check the feature access, configuration. I'm going to publish a shared instance map service, so I'll take the default there. Analyze. Analyzer throws an error because the layers data source is not registered to the server. Let's go ahead and register the Postgres database as the user-managed data store. Provide title, tags. The publisher database connection is picked up by default from the layers data source. The server database connection is going to be the same in this case. Hit validate. To check if the server can access the database, validation is successful. Hit create. Analyzing again to make sure there are no errors or warnings. That looks good. Publish. It is published successfully. I'm navigating to Portal Home Application. You can see there is a map image layer and a feature layer item that we just published from ArcGIS Pro. Let's take a look at the map image layer in Map Viewer.
Hosted feature services can be published from ArcGIS Pro. You can also publish formats like shapefiles, file geodatabase, CSV, Excel, etc. as hosted feature services directly to your portal. I'm going to demo publishing of hosted feature service from portal. Portal My Content page, add item from your computer. I'm going to browse and select a zipped file geodatabase. Contents, select File Geodatabase from the drop-down menu. Enter tags. Add item. It's creating the service. The service has been published. Let's draw the hosted feature service in Map Viewer. That looks good. Bulk publishing in ArcGIS Enterprise on Kubernetes. For bulk publishing, first we need to register an enterprise database to portal. This will be registered as a user-managed data store. We then create feature layers in bulk for the datasets from the registered database. I'm going to demo creating layers in bulk from the registered database data store.
I have made a connection to my SQL Server database in ArcGIS Pro. You can see this database has 5 datasets in total. I will be using this SQL Server database for bulk publishing. Into Portal Home application, My Content, Add Item, a data store. In step 1, I'm providing title, type, selecting database, providing some tags, hit next. In step 2, I'm going to browse and select the connection file for my SQL Server database. Leaving the rest default. Hitting next. You can see the validation process is happening in step 3. Validation status returned green. Add data store. The data store item is created and displays the item details page. Here select the Layers tab. Create layers. Step 1, provide a folder to which all your items will be saved. Step 2, if there is more than one server for your portal, you get to choose the server to which the services will be published. In this case, I do not have additional servers, so I leave the defaults and start publishing. Bulk publishing is completed now. My SQL Server database has 5 datasets. You can see here I have one map image layer and one feature layer for each of the dataset in my database. So totally 10 items have been created. Let's draw one of the feature layers in Map Viewer. Okay, that draws fine. Back to the presentation slides. Summary: publishing of services in ArcGIS Enterprise on Kubernetes is the same as publishing services in ArcGIS Enterprise on Windows or Linux. Users can access and use these published services just like they would use a service in ArcGIS Enterprise on Windows or Linux. Thank you for tuning in.
Hello everyone, my name is Garima Tiwari. I'm the product engineer for caching in ArcGIS Enterprise team. Today, I'm going to provide you a demo on how you can publish tile and vector tile layers in ArcGIS Enterprise on Kubernetes. Caching map and image content helps in providing fast visualization of your map data. You can pre-cook this cache content using geoprocessing tools in ArcGIS Pro. Map with vector content can be cached as vector tile packages, while map with vector, raster, or elevation content can be cached as tile packages. These can be uploaded and published as hosted tile layers to ArcGIS Enterprise on Kubernetes. I will log into my organization's portal. Go to Contents, select Add Item from your computer option to browse to the location where the tile package is present, providing necessary details to publish it as a hosted tile layer. The application uploads and publishes the tile content as a tile layer for me. And now I can share it with my desired group of users for usage in ArcGIS Map Viewer or ArcGIS Pro and other desktop applications. The same workflow can be used for publishing vector tile and elevation layers using ArcGIS Enterprise portal. To publish hosted tile and vector tile layers using ArcGIS Pro, simply open your map project, select Share as UI to publish web layer. Here select the Copy Data option to publish hosted vector or tile layers. ArcGIS Pro would create the tile package locally, upload and publish it as a hosted vector tile layers for you. And now you can consume these in your desktop applications or browsers in Map Viewer. To summarize, as a publisher, the user experience for publishing tile layers is the same for ArcGIS Enterprise on Windows, Linux, and Kubernetes. As an administrator, in Windows and Linux-based enterprise, you must allocate disk resources to your portal, content, and ArcGIS cache directories. Similarly, on Kubernetes, you must configure adequately sized persistent volumes associated with sharing pods and system-managed object stores. Publishing hosted tile layers requires uploading of the tile content to ArcGIS Enterprise. This process could become time-consuming and disk resource intensive if you have very large scene or tile packages. We now provide an alternative publishing workflow specifically for those of you who need to publish large pre-cooked tile, vector, or scene content to ArcGIS Enterprise. To achieve this in ArcGIS Pro, open Extract Package Geoprocessing tool. Browse to your pre-existing vector, tile, or scene package. For the output folder, you can choose a folder on file system or an object store in cloud such as AWS Esri or Azure Blob Stores. Now enable the option to create ready-to-serve format and run the tool. For example, here you can see that I have created more than 700 gigabytes worth of scene tile content in AWS Esri. I can register this bucket as a user-managed data store to my ArcGIS Enterprise account. To do this in ArcGIS Enterprise on Kubernetes, go to your portal home application, choose Add Item as a data store, choose Type as Cloud Store. In the next window, select the provider to be AWS and provide necessary credentials for your bucket. And now federate the data store configuration with your server. Now your user-managed data store is ready to be consumed for publishing of scene, tile, or vector tile layers. To do this, we have a simple script written in ArcGIS API for Python. This will connect to your Enterprise Publisher account, create scene service configuration using the path to the scene content in the user-managed data store, and publish more than 700 gigabytes worth of scene content in seconds. ArcGIS Enterprise will serve tile content directly from the registered user-managed data store for tile, vector, and scene layers. To summarize, these layers are ideal for publishing large volumes of vector, tile, and scene content. The tile content is served directly from the file system and object store. It has no restraint on your ArcGIS Enterprise disk or volume resources, and supports data resiliency and high availability as configured in the object store.
Hello, my name is Caroline Wright. I'm a product engineer on the ArcGIS Enterprise team. In this presentation, I'm going to discuss how you can federate a standalone ArcGIS server with an ArcGIS Enterprise on Kubernetes portal. What is federation? It's a process which links an ArcGIS server site with your ArcGIS Enterprise portal, automatically sharing the server site's content with ArcGIS Enterprise, and giving the portal control over the security and sharing settings of the server site. Services that exist on the ArcGIS server site at the time of federation are automatically added to the portal as items, as are all services published to the server site in the future. The version of ArcGIS Server being federated does not need to match the version of ArcGIS Enterprise on Kubernetes. It is possible to federate a server with an ArcGIS GIS server role. This role provides fundamental mapping and data management capabilities to your deployment. You can use an ArcGIS GIS server to publish services. Also, it's possible to federate a server with an ArcGIS image server role. Here you can take advantage of ArcGIS Image Server's ability to serve large collections of dynamic image services, which are web-accessible image layers. ArcGIS Server sites licensed with other roles, such as Geoanalytics Server or Notebook Server, cannot be federated. Once you've deployed ArcGIS Enterprise on Kubernetes, you can immediately begin publishing services and perform analysis. This contrasts with ArcGIS Enterprise on Windows and Linux machines, which need an ArcGIS server site to be federated and designated a hosting server as part of the base deployment. In Windows and Linux deployments of ArcGIS Enterprise, the hosting server is what enables users to create hosted layers and perform analysis. In ArcGIS Enterprise on Kubernetes, you cannot set server roles and cannot enable or disable feature analysis services for your organization. Both are set automatically. Now I will demonstrate federating a standalone ArcGIS server with an ArcGIS GIS server licensed role to an ArcGIS Enterprise on Kubernetes portal. On the left side of the screen, I have opened the ArcGIS Server Manager for a 10.8.1 deployment. The site is authorized with the ArcGIS GIS Server Advanced role and is using the GIS server as the authentication tier. This is a standalone server which I want to federate with my ArcGIS Enterprise on Kubernetes portal. I want to do this because I have a number of services published to the ArcGIS server which I would like to be easily discoverable and accessible in my portal. On the right side of the screen, I have my ArcGIS Enterprise on Kubernetes portal. I'm signed in as an administrator. I navigate to the Organization main menu tab and then click Settings Servers. For those of you familiar with ArcGIS Enterprise portal, you will see that the user experience for adding a federated server has been updated. This updated experience is available in ArcGIS Enterprise on Kubernetes, on Windows, and on Linux. Notice there isn't an existing federated server listed. The ArcGIS Enterprise on Kubernetes deployment includes an embedded ArcGIS server, which is the hosting server for portal. This is configured during the enterprise deployment process. Let's go ahead and add our standalone server. Start the process by clicking Add Server Site. Here you will see the same input options as you do in ArcGIS Enterprise on Windows and Linux. Once the federation process completes, the server will now be listed. Looking at my content, I can see portal items were created for the services already published to the server. These items are searchable and can be consumed in applications like the map viewer. Moving back to the ArcGIS Server Manager, I can now see the ArcGIS server is using Portal for ArcGIS as its authentication tier.
Hi, this is Morgan from the ArcGIS Enterprise development team. In this session, we will go over some conceptual details about GIS services in ArcGIS Enterprise on Kubernetes and how to manage and tune them. Let's look at services management. In ArcGIS Enterprise, your organization's geospatial capabilities are powered by GIS services. Your users can publish a wide range of services, making their maps, tools, data, and other GIS assets available on your ArcGIS Enterprise infrastructure. There are different types of services: map, feature services, geoprocessing, image services, etc. In this deployment, services run in containerized servers. Each deployment of ArcGIS Enterprise on Kubernetes hosts multiple servers, each operating a narrowly focused function. Because these servers are grouped in Kubernetes pods, they are quick, scalable, and isolated. If one pod shuts down, it doesn't affect the others. So dedicated services run in dedicated pod or pods, and shared services run in shared pods that have hosts multiple shared services. Here's a look at that in your cluster. So we have many services running in this cluster, and as you can see, there's the USA map service, which is a dedicated service, and there's multiple pods of that particular dedicated service running here. You also have one or more pods of the shared mapping host, one here and one here. And these are the shared mapping host servers that hosts all of your shared instance map services. Additionally, you also have the hosted feature server pod, which basically hosts all of your hosted feature services. GIS administrators should regularly monitor and review their service for performance. If a service in your organization is receiving high traffic, users may experience performance delays. It's important to understand the signs of an overburdened service and to know how to scale the service to meet higher demand. This is one of the central tenets to service management, tuning and scaling your GIS services. In this deployment model, the essential scaling unit is a pod. Scaling basically involves scaling up or down at the pod level. For dedicated services, you increase the number of pods running for that service. For example, the USA map service that you saw in the previous slide. For shared services, you increase the number of pods running for the shared host that is hosting the service. Similarly, for hosted feature services, if you want to scale some hosted feature services out, you would increase the number of pods for the shared feature server. And this would basically scale out the pods and basically scale out all the services within that. You can also add more resources to any of these pods by adjusting the min-max memory and CPU as required. You would need this to handle cases where a large amount of data is being loaded into memory for some services, or large queries are being executed and things like that. Another note here is that as you start to plan to scale out your pods and your deployment, you want to make sure you have enough resources in your cluster to handle this. So that is something you always want to check and add as necessary. In cloud scenarios, the nodes are scaled or added as needed or required automatically by the cloud provider. So as you can see here, this is the landing page for services. It is essentially a service catalog. It will list all the user-published services with details like the name, the type of service, map service, feature service, etc., within the folders that are created by the administrators. So once you click on View Details, you'll get a view that shows the overview of the service. Here you can configure or tune your service. If the service is started, you can proceed to stop the service. If it's stopped, there will be a Start Service button. You can update mode from dedicated to shared or vice versa. And importantly, you can also scale the number of pods for your service up or down using this scaling section. So this is where the pods running your services can be updated. Additionally, you can configure the resource limits on the pods that are running for the service, the memory min, max, and the CPU min-max. As an admin, if you're aware of the shared host service or pods that hosts or there are hosts for the shared instance map services or hosted feature services, then you can directly go to a special setting here to configure these, called configure shared resources. You will see currently two types of servers or services listed. The shared feature service, which hosts all the feature services in your deployment, and the shared map service, which hosts all the shared map services in your organization. You can configure then the scaling of pods as well as the resource limits, and additionally set the max time a client can use any service that is being hosted by the shared resource. So this is the kind of the central place that you can come to directly to scale out and set resources and the usage timeouts for these shared host servers or services.
Hi, my name is Jeff Smith, and I'm a product engineer on the Enterprise team. I will be discussing today some of the new features in Enterprise on Kubernetes related to security and authentication. TLS certificates are just as important in Enterprise on Kubernetes as they are on Windows and Linux, and they are used in very similar manners. The workflows to import and assign them is different though. On Windows and Linux, we group all of the certificates into one bucket regardless of their purpose. In Enterprise on Kubernetes, we have split the TLS certificates into two categories based on their purpose. We refer to them as identity certificates and trust certificates. Identity certificates are the equivalent to the existing server certificates that are imported in the admin API on Windows and Linux. They are used to identify and prove the ownership of a server or other resource. On Kubernetes, Instead of importing and assigning a certificate to the internal Tomcat for port 6443 or 7443, you will need to import and assign a certificate to be used by the ingress controller. Trust certificates are the equivalent to the root or intermediate certificates imported in Enterprise on Windows and Linux. They contain information about a certificate issuer or certificate authority and are used to validate identity certificates from external resources. Now, just like on Windows and Linux, we will inherit a default group of trust certificates for the well-known certificate authorities from the embedded Java. The ones that are imported manually through the Enterprise Manager, as I will display, are for non-default or non-well-known CAs. During the deployment process, you will now have the option to select what identity certificate the ingress controller uses. This means you are not forced to use a self-signed certificate to initially access and run the create site operation. Now you can still generate a self-signed certificate here if you need to, or you could import and use a CA signed certificate. This certificate could be a standalone PFX file, a pair of public and private key files, or a native Kubernetes TLS secret. Another important change is that once the deployment is completed and the site has been created, TLS certificates can be fully managed through the Enterprise Manager instead of relying on the admin API. I will give you a brief demo now to show you what this looks like. This is the Enterprise Manager page. I want to click on the padlock on the left to look at the security page. This page is not completed yet, so we don't see everything here that will be available, but we do see the active TLS certificate and the identity store information. The self-signed certificate for the ingress controller that was created at deployment is stored in a TLS secret, as we see right here. When we click on TLS certificates, we see a list of identity certificates, trust certificates, and the TLS secret here. For the identity certificates, I haven't imported any, so let's go ahead and import one right now. Now once imported, we see the name with the alias, who it's issued to, who it's issued by, and the expiration date. I can import any number of identity certificates here. They are not used until they are assigned to a resource. On the far right, we see the assigned to column. Now what's happening behind the scenes here is a new pod for the ingress controller is being generated with this new configuration change using the wildcard certificate that I've imported here. Once it's fully up and running, Kubernetes will handle terminating the old ingress controller pod. And in doing so, it makes it so from the end user's perspective, there's very little, if any, downtime during this process. Now when I go on back to TLS certificates, I can go to TLS secret. This is where I could specify a native Kubernetes secret for the ingress controller. This is where we can handle and import trust certificates. Let's go ahead and import a copy of our Esri root certificate. Click import. Again, we can import any number of these. Once they're imported, this new certificate is actually shared among all of the pods. And any pods that actually need to get regenerated, that happens behind the scenes, or anything else that needs to get to reread these new trust certificates, it'll happen automatically. The good news about user authentication for Enterprise on Kubernetes is all methods that are supported on Windows and Linux are fully supported on Kubernetes. This includes support for both portal tier and web tier authentication using either Active Directory or LDAP users. The main difference is how some of the identity stores are configured. Configuring SAML or OpenID Connect users has not changed and is still done through the Home app. Configuring built-in Active Directory or LDAP users and groups has changed though, so I want to dive into those changes a bit more. New in Enterprise on Kubernetes is the ability to configure the identity stores through Enterprise Manager. We can now enter each parameter directly through Enterprise Manager. For built-in users, as I've got on the screenshot here, it's still the default configuration and no extra parameters are needed to use these. For LDAP users and groups, the parameters that need to be specified on Kubernetes are identical to what is needed on Windows or Linux. Once the identity store is configured, portal tier authentication is available with no additional changes needed. For web tier authentication, we need to install and configure a web adapter. Now, unlike Windows and Linux, the web adapter on Kubernetes is not a required component. In most cases, a reverse proxy or load balancer will work perfectly fine in place of the web adapter. The web adapter is only required if you want to use web tier authentication.
Hello, my name is John Quinn and I'm here virtually with Lawrence Clinton. In this presentation, we're going to talk about high availability and disaster recovery in ArcGIS Enterprise on Kubernetes. First, we'll talk about backup and restore. We'll touch on what is included in the backup, where it's stored, and how to restore it. Next, we'll discuss high availability. First, we're going to give some context as to how Kubernetes will assist in failure detection. Then we'll talk about different architecture profiles, and finally, go through some failure scenarios in a demo. So backups are going to be integral to minimizing data loss after a disaster, outage, or even data corruption. Now in ArcGIS Enterprise on Kubernetes, backing up a deployment and restoring it is integrated within ArcGIS Enterprise within the framework of the software, as opposed to an external client-type tool like the WebGSDR tool within ArcGIS Enterprise on Windows and Linux. Just like any backup utility, it's important to understand what's included in the backup. And there's several categories of data and settings that have to be included. First, obviously, is any customer data. Next, configuration information is also stored in the backup. And finally, any Kubernetes infrastructure objects are included. Things like config maps, secrets, things that dictate how many stateful sets and replica sets is all included within a backup. So when you're ready to create a backup, there's a couple different places that the backup can be stored. The first is going to be supported by a persistent volume. And here you can store it in a hosted backup store. This is a container that will store the backups, or directly on the file system, something that is browsable within the file structure. We're also going to support native cloud storage, for example, storing a backup within an S3 bucket or within a blob container in Azure. When you're ready to restore a backup, the Kubernetes objects, the things that Enterprise relies on within the environment, has to be restored first. Once that's done, any of the configuration data is restored. And finally, all user data. So all the content that was created and present in the deployment at the time of creating the backup. So before we get into ArcGIS Enterprise high availability, I want to quickly cover how Kubernetes aids in maintaining availability and the self-healing concept of a system that runs within Kubernetes. So a pod can have multiple containers in it, and all must start up successfully for Kubernetes to determine that the pod is running. Kubernetes tracks container states and determines what action to take to make sure that the pod is healthy again. So when a pod is starting up, it's entering into this pending phase. If at least one container starts up correctly, it's in this initializing phase. If all containers start correctly, then the pod is up and running, and the phase is running. However, if at least one container fails to start, then it enters a failed state. Kubernetes will then attempt to terminate and recreate the pod on the same node or a different node. So probes are used to determine whether containers in the pod are running and whether those containers are ready to accept requests. So the first probe is a liveness probe. Did all the containers start correctly? If they did, then Kubernetes is going to use a readiness probe. Are all containers ready to accept requests? So both of these need to pass for the containers and the pod to be seen as running. So much like any other system, ArcGIS Enterprise included, there is no one-size-fits-all for architectures. When designing ArcGIS Enterprise in Kubernetes, we wanted to make sure it was easy for an administrator to decide what architecture profile best fits them. The first architecture profile we want to support is this development profile. And this is designed for a non-production environment, and it's going to be easy to deploy. There's no mandate for HA, so there's less resources required to deploy a development environment. Here's a conceptual diagram of a Kubernetes cluster with two nodes with a development profile deployed. Now, with the exception of the relational data store, there are single points of failure throughout the deployment. So we're still going to rely on Kubernetes to reschedule pods that have failed, So even if this is a development environment, there is still a concept of recovery. So these profiles that we've designed are for production environments and for organizations that have an HA mandate. In general, they follow HA fundamentals, like having no single points of failure. This both increases redundancy but also scalability for the deployment. So the first profile we have is to support a minimum to moderate amount of downtime. There is going to be a potential loss of functionality in the event of a specific type of failure. I'll go through that soon. And this is going to be appropriate for medium-sized customers. So here's a conceptual diagram of the first profile that we want to support. There are going to be multiple ingress controllers, both external and internal, and multiple administration pods. This is the Enterprise Admin API and Enterprise Manager, or multiple pods of system services. These are services that support publishing or caching or spatial analysis. There's multiple pods of APIs and apps. For example, the home application or any of the built-in applications that you can create apps from. And next is the object store. So the object store stores user-created content within the organization. Now for high availability for the object store, it requires that more than half of the number of pods or PVs are available. If half or less are available, the object store will be read-only. Content will still be accessible, but you won't be able to create any new content. Now it's going to be read-only for the amount of time it takes for Kubernetes to detect the failure and then reschedule the pod on the same node or a different node. And next is the index and log store. So these store the data that's used for searching and for storage of logs. And it requires at least 3 pods to be highly available to achieve a quorum during primary selection. Each pod will operate as both a coordinator node and a data node in mixed mode. And coordinators ensure that each pod knows which is primary for managing the cluster, and data nodes support storing and querying of data. So with this first profile, each index and log store pod are both a coordinator and a data node. The second profile we want to support, specific to high availability, is for organizations that require higher tolerance for failures or support more users. So this will support a minimum amount of downtime and no potential loss of functionality in the event of a failure. And this is going to be appropriate for large-sized customers. There's a 3-pod object store cluster, which ensures that even if one goes down, there's still more than half of the pods available, which means that users can still create content within the deployment. And this ensures there's no business disruptions. Next, the index and log store operates in a dedicated mode rather than a mixed mode. So dedicated mode ensures that there are separate pods for the coordinators and the data nodes. So there will be 3 coordinator nodes and then 2 data nodes. So you can assign different resource limits to data nodes and coordinator nodes, and if you require a higher level of throughput for data nodes, then again you can scale those easier than if it was in a mixed mode. For the number of logs and index store pods, there are 3 for profile 1 and 5 for profile 2. Even though in 5 for profile 2, they're in this dedicated mode, while in profile 1, it's in this mixed mode. Next, if there is an object store pod failure, in the time that it takes to recreate the pod that failed in the first profile, the deployment will be read-only, which means nobody can create any new content, but content will still be accessible. In the second profile, you're still read and write. So users within the organization, any publishers, will still be able to create content.
Hi, my name is Lawrence, and I'm a product engineer with the ArcGIS Data Store team. We will be discussing the role and purpose of the different data store types in ArcGIS on Kubernetes. For the relational data store, it uses a primary standby architecture. As data populates to the primary, it streams to the standby. There is logic also to perform health checks on both the primary and standby pods. If any issue is detected, then action is taken. And depending upon the scenario, that action could be restarting or refurbishing the pod, for example on primary, or a liveliness check, or invoking failover such that the standby role changes to the primary role. For the object store, its architecture is that of a standalone associated with one persistent volume, or has a cluster of nodes with multiple of 4 persistent volumes where data is replicated. Liveliness and readiness checks are also there, and they monitor the health status of the pods in the cluster. In case of the object store, if there is a failure, as long as there are greater than half of the nodes and disk available, you can read and write to the object store. Finally, the spatial temporal and index store incorporates an architecture that uses sharding, whereby indices are composed of smaller shards, and these shards are also replicated. If there's a problem with the primary shard, the replicate can be promoted as primary. And like the relational and object store, liveness and readiness checks are used to monitor the health status of the various pods. Now, one way to emulate a failure on a pod is to actually delete the pod. And in this case, we're going to delete the primary relational data store pod, which is this one right here. So by right-clicking and deleting it, what we're going to see is on the right-hand side, our feature service slowly disappeared as it's no longer able to draw data from it. So we're going to refresh, and we will wait for the liveness probe to refurbish that pod, and our feature service will come back into view momentarily. Now, as you can see, our feature service is now back.
Hi, this is Morgan from the ArcGIS Enterprise development team. In this short session, I will provide a brief of the APIs that power ArcGIS Enterprise on Kubernetes. There are 3 main APIs that power Enterprise on Kubernetes: the Administrative API, the Sharing API or Portal Directory, and the Services API. The Sharing API is something that you've already been used to. This is the traditional sharing API in Portal for ArcGIS for managing users, groups, and items. It's got a nice HTML view. There is no change from Windows and Linux for the sharing API in terms of ArcGIS Enterprise on Kubernetes. It is backward compatible, and there's no changes that's happened here. Next, the Services API. This is the API that's used by GIS services for their operations and resources that you see on each of the individual GIS services in your organization. Again, this API, there is no change from Windows and Linux, and it is fully backward compatible. So the main thing that we want to talk about is the Administrative API, because here things have changed. We have a new Administrative API, which is a single admin API for ArcGIS Enterprise. And this replaces the portal and server admin APIs and incorporates some of the APIs from both into it. It is not backward compatible with a few exceptions. So this is something that's new, and if you have programmed against the Administrative API, this is something that you will have to come in and change accordingly. The admin API, the portal directory, and the services directory are all represented as pods. They run as pods within your cluster and within the ArcGIS namespace. So that is one big difference here as well. Everything is a pod, is running as a pod, and including the APIs independently. And depending on the profile you have selected during your deployment of your enterprise, and after configuring your organization, you will see one or more of these pods running. So this is the ArcGIS Enterprise administrative site directory. You'll reach this page by going to the fully qualified domain name /context of your reverse proxy or the web adapter and appending /admin at the end of it. Now we are at the root resource of the Enterprise Admin API. Let's go through some of the resources here. First, we have the organizations resource. I'll have an organization ID, and there's security that manages groups and users, federation, as well as licenses. Let's go to the services API. Now this is the API that you're used to in the server admin and it lists the list of folders. It's a catalog of folders and services inside those folders. So here we can see that at the root folder we have a few services, and we also have system and utilities folders and any other folders that you would create and put services inside of them. You can see in under system the services that you're familiar with, like publishing tools, caching controllers, caching tools, sync tools, etc. If I go to a specific dedicated service, you'll see the service JSON for that service, and also operations like start service, stop service, edit, and delete service. And also this new resource called scaling, which allows you to scale a dedicated service out by scaling the pods and the number of replicas of the pods. You also have a security resource where you'll do configurations like SAML certificates and Ingress certificate configuration. These are all represented in ArcGIS Enterprise Manager, and this is the API that powers that. We also have a data stores API. Again, this kind of replaces the data stores API that you're familiar with, and this lists the hosted data stores that power ArcGIS Enterprise on Kubernetes, as well as any user-managed data stores if you choose to register those as either enterprise geodatabases or any file shares where your data is contained. Let's go to the system resource here, and there are APIs for upgrades, for disaster recovery, which is backup and restore, and web adapters. A new API that's come up in this deployment model is the deployments API. This API lists all the pods that are running inside of your namespace. You can go to a specific section here and scale out individual pods as required. But you can, for foundational pods, you can go to individual ones here. For example, if you go to the enterprise portal API, which is the sharing API, you can actually scale that the pods of that API out by updating it here. So those are what I wanted to cover with the administrative API.
Thank you for joining us at Developer Summit 2021 and participating in this session about ArcGIS Enterprise on Kubernetes. We hope you found it helpful, and we hope to hear from you soon. Please enjoy the rest of the conference. Hello, and thanks to everybody who's been watching. I'm Trevor Seaton on the ArcGIS Enterprise product management team, helping to moderate some of the questions coming through here. So in this session, our team has demonstrated some of the exciting changes that are coming with this new deployment option for ArcGIS Enterprise on Kubernetes. We'll respond to as many questions as we can, and there will be a recording available of the session. So with that, let's just dive into some of the questions. And let's start with several questions that are around Oracle. There are questions around whether Oracle is excluded or maybe not supported with the initial launch. There's probably a category of questions here. So there are some nuances, and I'm going to ask Eva to introduce yourself and then provide us with some answers here.
Hi, I'm Eva Moy, and I'm the lead product engineer for the ArcGIS Enterprise on Kubernetes. And so to answer that question is that we do not support Oracle database out of the box. What that means is that you would not be able to register an Oracle database from portal directly on Kubernetes. But what you can do is that you can still register the Oracle database from your GIS server that are running on Windows and Linux, and you publish a service through that. And then you would be able to federate that GIS server on the portal on Kubernetes. The reason why we cannot support this is because the Oracle, our container is Ubuntu based, and Oracle does not officially support Ubuntu. So ESRI has been trying to work with Oracle in this regard, but at the same time, please bring your requirements to Oracle, to your Oracle representative. Thank you.
Thank you, Eva. I'm going to take the next question, and it is, do you anticipate that the functionality of ArcGIS Enterprise on Kubernetes will diverge from ArcGIS Enterprise on the more traditional infrastructure over time? And it's really important to say that the answer is no. This is one product, ArcGIS Enterprise. In fact, to achieve this launch with a new redesigned architecture, we've had to defer some functionality primarily outside of the base enterprise deployment. Rather than diverge, our intent is to give users the same portal and services experience that they have with Windows or Linux, and they really shouldn't care about the underlying technology. So we will actually be moving more closely to parity with the Windows and Linux deployment options over time. And more information around these differences will be shared as we approach their actual launch, and we do encourage you to reach out to us directly under Ask Our Experts under the ArcGIS Enterprise channel, or reach out to your Esri account manager. Thank you. Next question is, do you support CloudFormation and or Terraform to deploy ArcGIS Enterprise on Kubernetes? Shreyas.
Hi, my name is Shreyas. I'm the lead developer for ArcGIS Enterprise on Kubernetes. That's a good question. So CloudFormation and Terraform are technologies that sort of let you work with virtualizations and virtual machines. With Enterprise on Kubernetes, actually the underlying provisioned software is a Kubernetes cluster, and it's easy to provision a Kubernetes cluster on the cloud on AKS and on Azure, Azure on AKS on Azure and EKS on AWS. So you don't really need to use Terraform or CloudFormation to deploy it, because it's already sort of packaged nicely for you. And to deploy Enterprise on Kubernetes in Kubernetes on the Kubernetes cluster, you just use our deployment scripts that were demonstrated earlier. Back to you, Trevor.
Thank you, Shreyas. Appreciate that. I'm going to answer another quick question here. When will the Kubernetes version of ArcGIS be available for testing, and what ArcGIS version on Kubernetes will be production ready? So we are essentially approaching our launch very shortly here as part of the ArcGIS 2021 release in Q2. Over the coming weeks, you'll hear more about this, and we do expect to launch next month, as early as next month. So please stay tuned. Next question, I'm going to jump down a little bit. It is, does the portal provisioned with all extensions installed, such as Insights, Office, Workforce, and more? Maybe talk a little bit about that, how much is installed, and kind of the thinking around that. And I'm going to ask Caroline to respond to that.
Hey, yep, my name's Caroline Wright. I'm a product engineer on the enterprise team. So at 10.9, we are planning support for Office, Workforce, Survey 1, 2, 3, and the field maps. Any verification by the client teams, by the application teams, will really determine whether those apps are finally included. But at this time, that's what we're planning. Insights is not planned for 10.9, but any inclusion is subject to final verification by the application teams.
Thank you, Caroline. I'm going to go to Garima next for a question about why are you building the tile layers on the desktop rather than in the cloud?
So there are many cases where you pre-cook your cache content, your vector content and scene content in desktop, and you want to share those content with your users. And that's what we demonstrated, that you can bring in your pre-cooked content and share it as a hosted tile layer or reference tile layer where the content is being served from Esri or Azure Blob stores. At ArcGIS release build of Kubernetes, you would be able to use the Kubernetes infrastructure to generate caches for map services and use the scaling facilities available in Kubernetes to generate caches in there. And the caches would be generated in object stores maintained by ArcGIS Enterprise, as well as you can write to object stores in cloud, such as AWS S3 and Azure Blob stores. Hope this helps. Thanks, Trevor.
Thank you very much. Appreciate that, Garima. Jeff, let's ask a question about security. Can we use SAML authentication on Portal as it is available now?
Hi, my name is Jeff Smith, and I'm a product engineer on the enterprise team. And in response to that question, yes, the SAML can be fully supported on ArcGIS Enterprise on Kubernetes, just as it is on Windows and Linux.
Thank you for that. Appreciate it. There's a question about licensing here. So how is ArcGIS on Kubernetes or Enterprise on Kubernetes licensed, per user or per core? That's a great question. There were a lot of different ways we could have gone with this. And we decided, because it's a brand new architecture and a kind of a newer administrative experience, to keep things very simple. If you're an enterprise customer with an active enterprise agreement, and there are a few other kind of eligibility requirements, we want to have a conversation with you. But having an enterprise agreement would potentially make you eligible for the Kubernetes technology. And we want to have that conversation, but there will not be additional licensing or pricing at the time that we initially launch for access to ArcGIS Enterprise on Kubernetes. Let's scroll down a little bit to a question which is about, will ArcGIS Enterprise on Kubernetes work with on-prem or on-premise SQL Server databases? Eva, please.
Yeah, the answer is yes. Out of the box, ArcGIS Postgres and SQL Server database will be supported with ArcGIS Enterprise on Kubernetes. Thank you, Trevor.
Thank you very much. There's a question here about migration. So is or will there be documentation on how to migrate a current on-premise Windows site to Kubernetes on Azure Cloud, and tools to help with the update process? So the short answer of the documentation question is yes. We have a long history of building pretty robust documentation to help customers with patterns like, moving into or between environments. So that will absolutely be our objective here, is to help with that documentation. Migration itself is actually quite complicated. We're absolutely working on this. We had to make some trade-offs once again with the initial launch, and because there are so many permutations in different types of environments and where content is and how things are configured, there is not going to be some kind of an easy button or some way to quickly shift you from Kubernetes or from Windows or Linux directly into the Kubernetes architecture. So this is going to be ongoing discussion within our team. We need to come up with some really clear strategies around this. And it might vary depending on, your individual deployment situation or the sector you're in, and some of the extensions you might be using. Not to mention the apps you're using, extensions or interceptors you're using, federation, and so forth. So more to come on that. But the short answer is yes. Documentation, no to an easy button to just kind of move you directly into Kubernetes. I'm going to ask Gayatri to respond to a question here about can you publish map services in Kubernetes? Can you select the server that the service is published to? And is there a limit to the number of services that can be published? So kind of a three-parter there.
Hi, I'm Gayatri, publishing product engineer. And yes, you can publish map services to Kubernetes, and you can from ArcGIS Pro. And you can also, when publishing map services from ArcGIS Pro, there is an option to select outside of Kubernetes server. You can also select any federated server and publish your map services to the federated server. And there is no set specific limit. In Pro, yes, you have a limit, but if you're bulk publishing, you can publish any number of services, and it depends on your system resources. Thanks, Trevor.
Thank you, guys. We appreciate that. Let's go to Morgan. We had a question about the minimum pod specifications, recommendations for the pods, and whether that might change depending on the functionality a pod might be planned for. Morgan, can you speak on this?
Thanks, Trevor. Yeah, my name is Morgan Raj. I'm a product engineer on the team. Yes, the pod specifications do differ based on what type of pod it is. Essentially, there are three types of, if I want to categorize it in that way, there are three categories of sets of pods. There's the foundational pods, which are your components like the administrative API, the sharing API. They are called the foundational pods, if you want to call it that. Then there's also the GIS server pod. So all the GIS services are also running as pods inside your cluster. And then there's also the data store components that are also running as pods within your cluster. All of these have different requirements in terms of usage, in terms of HA, and also in terms of how many pods of it you want. So depending also on the GIS service type, for example, GP server or GP services probably have more of a memory requirement, for example. So depending on all these things, we have curated it in the best way we can, and based on our internal testing at 10.9. But we would definitely recommend you to try it out, and then based on your requirements and your needs, and the kind of traffic you're getting, and what the use cases for your deployments are, to curate them additionally to suit your purpose. Thanks, Trevor.
Thank you. Appreciate that, Morgan. We might have time for one more question or possibly two. John, maybe you could speak to this one. Will any of the architecture modifications from ArcGIS on Kubernetes be brought back into the enterprise-based deployments?
Sure. Thanks, Trevor. So my name is John. I am a product engineer focusing on high availability and disaster recovery. At this point, it's unlikely that any, likely not possible that any of the architecture that has been designed for ArcGIS Enterprise and Kubernetes will be brought into Windows on Linux based on, the fact that they're containerized and there's no concept of containerizing all the different pieces of the software on Windows and Linux. So it is unlikely that the changes made for ArcGIS Enterprise on Kubernetes will be introduced in Windows and Linux.
Jeff, does ArcGIS Enterprise integrate with Windows Active Directory? Real quick.
Hey, Trevor, thanks. Yes, the ArcGIS Enterprise on Kubernetes fully integrates with Windows Active Directory just as we do on Windows and Linux right now. So that means you can use your Active Directory Windows users and groups and log in with them just as you can now on, like I said, on Windows and Linux.
Thanks, Jeff. Thank you, everybody. We've approached the end of this session, so we may not have gotten to every question. Please be sure to go to Ask Our Experts. You will find a channel on ArcGIS Enterprise, and we absolutely hope that you enjoy the rest of the Developer Summit. And thanks to our team here for responding to questions. Good day.
Thank you. Good day.